Thank you all for being here. We're excited to be here and share with you some of the work we've done around OpenShift at Cisco. Our goal as an infrastructure provider is really to provide cloud infrastructure for all of Cisco IT developers. And so Mike and I both work, Mike and Mike, we both work in global infrastructure services at Cisco, and we've been there a long time.
Some longer than others.
Yep. So let's jump into the presentation. So our platform that we offer at Cisco is codenamed CAE, Cloud Application Environment, and really this is the platform that we've built on top of OpenShift 3.
Our CTO came up with the name.
Yeah. The key thing for us is really the scale that we deploy at. So we're currently deployed across 3 different data centers in 2 different geographies, and our goal is to support thousands of internally developed applications. So we're scaling up to support 2,000 plus applications, looking to run tens of thousands of containers, and these support all the different lines of business. So our internal HR apps, our supply chain applications, and even our commerce and go-to-market applications.
So when we set out to build out this new iteration of OpenShift for Cisco, we had a couple guiding principles kind of going into it. The first off, and one of the biggest drivers for us to actually adopting OpenShift 3 was our desire for a multi-tenant environment. A lot of the other current container scheduler solutions, even around Kubernetes, are not multi-tenanted. And one of the big drivers for us is to utilize the efficiencies that containers bring into the ecosystem to take multiple different use cases and pack them all on bare metal servers and utilize those suckers up without taking the hypervisor tax. And we've been seeing some cool utilization from that. The second guiding principle to it is that we didn't want to be a restrictive environment. For some of you who might be working for larger organizations, you probably know that typically the larger the organization, the more policy and process and red tape that's involved. And we wanted to make sure that the environment was empowering our developers to really do what they needed to do, and that we didn't stand in the way of enabling them to create the first-class applications that we know they're capable of.
Can I jump in here, Mike?
Yeah, please do.
We have also an LAE environment, which was OpenShift 2.0 based, and this is really where we're trying to step from a pure platform as a service to containers as a service. So that empowering the developers goes all the way to offering beyond the normal templated applications that you'll get with a PaaS play, right? That you can pick and choose the technologies that you want to use, assemble them in microservice applications, and then deploy them on our platform. So we call it PaaS++ or container as a service, and that's what we're trying to enable here.
And we'll talk a little bit more about that kind of concept in a little bit. Kind of tying in with the multi-tenant environment, we want to promote efficient resource utilization. We didn't want to lose roughly 15% of our compute processing to hypervisors. We didn't want to stand up and eat the management overhead of multiple different schedulers. We didn't want to carve up our infra unless we absolutely had to. So that was another guiding principle for us. And then fourth, and this is definitely not least, we needed to make sure that we secured and we protected the workloads running on this environment.
Yeah, so even though we want to enable all the developers, right, we want them to do the right thing. So we've got to put some rails on the process so they don't go too far out of line.
And that was served more as a counterbalance than a dictation to the empowering of our developers on the environment.
Yeah. Okay, so I'll take this one. So all our developers, like everyone in IT today, are enamored with all the great things that you can do at Amazon or Google or Azure. They really want to have that freedom to program against their infrastructure, right? To treat infrastructure as code and to do all these DevOps-y processes. They really, really want that. And if they've got enough budget and an influential enough director, they'll go out and they'll start at Amazon. And we always ask them, why'd you go there, right? And they come back with this litany of services that they're going to use from Amazon, right? They're going to use EC2 and S3 and all the networking components. They come with this laundry list. And up until recently, we said, yeah, we can't do that. We don't have programmable infrastructure that you guys can use. And many of them went out there. But when we talk to them and really try to understand what they're looking for, Amazon EC2 is really the ability to dynamically provision compute capacity, right? To be able to scale, to be able to deploy in multiple regions. So when we understood that requirement, we can start making some progress. S3, they're looking for all different kinds of storage for all different kinds of use cases. For a simple web app, just storing some content, you don't need the high-powered storage. But if you're going to run a big data service, you need that high throughput, low latency kind of storage. As far as the network goes, what the app developers were most looking for was the ability to control request routing. Can I send some of my users to, one geography, another set to another? Can I use that in my deployment process so that I can do A/B deployment and those sorts of things? So they were really looking for control over the request routing. Additionally, we've got lots of apps that want to use a web app firewall, and that was a capability that we wanted to provide. And so as you look across all the capabilities that they were asking for at Amazon, we found out, well, at Cisco, we have all of these technologies. We have all of the different compute and storage and networking solutions that you might want. It's just that they weren't exposed programmatically. So OpenShift became a facade or a layer of abstraction, if you will, that helped us translate the requirements that they came with to the services that we were providing. So we still don't offer, EC2 programmable instances. We have self-service versions, but not programmable versions. But we use OpenShift to kind of be that common layer, that API that our developers can program against in order to get compute, storage, and networking. At the same time, we've integrated it with an enterprise container hub and our continuous delivery, continuous integration pipelines to make this a whole solution. And we'll talk a little bit more about that on the next slide. So if we're going to provide programmable infrastructure to our development communities, we've got to really handle the whole life cycle. So we're starting out from provisioning. Much like the Swiss Railway example, we have a whole system built for self-service provisioning that's API enabled and programmable. So right from the scratch, the development team can come and say, hey, I need a project, I'm developing this application, and we'll allow them to get started, create that project, and establish their tenancy. This ties back to all of our planning, budgeting, and other systems within Cisco as well.
It's actually fairly similar to the SBB setup that you guys were just demonstrating earlier.
Yep.
We were laughing. It's like, man, we're almost identical in the approach that we're trying to take in adopting this type of stuff.
Yep. So once you've got your infrastructure provisioned, your next step's off to building your application. And so we've got an enterprise container hub. Like everyone else, we've got Git and Jenkins, and those are building your application's WAR and tar files, checking them into a version repository, and then having to merge them with an image. And so we'll do that build process, stick the image in our enterprise container hub, and it's from there that we'll pull it into the container runtime environment. I wanted to say one more thing on the previous one. So once you've got the app out and running in OpenShift, in our CAE environment, now the developers will interact with the platform itself through the APIs. And we've been very conscious about making sure that we leave the APIs open because we want this to be a programmable infrastructure. And in fact, if we go to the next slide now, this layer of cloud APIs is a layer that we've built maybe in lieu of or while waiting for API federation. but also as a way to provide programmable interfaces across that lifecycle. So we've built some cloud APIs in Cisco that will allow them to manage all those different life cycles, as well as manage our federated cluster. The container platform, OpenShift, is obviously the core, and underneath it all, we've got our infrastructure services. But that cloud API is really important. For technologies that don't have a multi-tenant cloud-based API, we've built one in front of it. So if you think about the load balancers and even some of the what else did we put one in front of? The storage systems.
There's other technologies too that sometimes claim multi-tenancy, but when you deep dive into it, it doesn't provide the multi-tenancy options that we needed. So oftentimes it was expanding upon functionality that vendors would provide to meet our customer needs.
And I remember one more thing. In order to provide an end-to-end stack, you've got to orchestrate amongst various services. So just running and deploying your application in OpenShift is great, but what if you need to create a firewall rule or a presence on the DMZ? How do you get that done? So we're trapping events as they come out of OpenShift and passing them back to these cloud APIs to orchestrate things like certificate creation, DNS registration, a whole laundry list, registering them with our enterprise monitoring system. We do a whole bunch of extra orchestration tasks so that when the developer says, I want to expose this app at a route, they get all these other components from end to end.
For me, one of the coolest things about this was automatic generation of certified SSL certs, which I just thought was the coolest thing ever personally.
Yep. All right.
So I was very sad to hear that Nintendo was canceling the Nintendo Classic. So my little slightly adjusted Mario figurine, so we won't get sued for copyright infringement. He's wearing blue, not red, and it's white pants instead of green, so hopefully that's enough. But as many of us have been talking about, this is an evolving technology stack and solution. And there's a lot of stuff that's been done. In fact, I'm shocked at how quickly this community has developed and put together feature sets that rival pretty much anything else in such a very short time. But there's still a long roadmap of features that we still need. And so I kind of want to talk about, and super cool animation, right? Some of the feature gaps that we started. In fact, do you guys want to see it again? Because it took me a while to figure out how to do pathing in PowerPoint. So
he spent about 14 hours creating just this one slide.
Just that one jump, yeah. Mario's got to jump. I was thinking, maybe I'll put in a little mushroom so he grows. Anyways. So kind of where we're at now, we were trying to again just bridge that what we get out of OpenShift out of the box, which is fantastic, and how do we adapt that to our specific use case and need. And so one of the first things we realized we needed was a unified experience across all of our clusters. So currently we have 3 clusters, 1 cluster per data center, and that constitutes our availability zone within our uptime calculations. And there was no good way today, and we're eagerly awaiting for federation, to handle kind of user tenantship and things like that, as well as API access across all those things that Mike has already talked about. And so we had this thing called ACC, which is kind of our front-end user interface for billing, chargeback, user management, tenantship, stuff like that, RBAC, and then CAPI, or the cloud API that Mike was referring to earlier. In addition to that, there's the Kubernetes Service Discovery is fantastic. It works very well within the cluster, but there's no way today to do service discovery across multiple clusters. And one of our first big clients, they're working on a identity federation warehouse. And they have like mini clusters of Cassandra databases that then need to see when new nodes come up in different clusters. And there's just no way that we could do that through Kubernetes. So what we ended up having to do was enable certain specific use cases like this one app to deploy their own service discovery application of their choice, and then install agents across the pods on all the different clusters to kind of hedge our bets for now until we get that proper federation. And in this case, they're using Consul. And sorry, I thought I had closed everything down. One moment. There we go. Yes, I am definitely sure I want to close box sync. There we go. The other thing that, and we're very interested in hearing about all the work that's being done in this area today, ingress and egress control. And so again, when we're talking about multiple clusters, not just northbound of OpenShift, but even between clusters, we quickly realized that we needed some ways of controlling what traffic could be exposed where and what traffic could be intaken from where. And there's really no good way of doing that today. Fortunately, Ben, who was over here earlier, huge call out to him. He helped us out a lot, and we did a lot of work on getting the ingress controller set up so that we could publicly, outside the OpenShift cluster, avail certain services with their own public IP address so it could be reached from other clusters. But there's still a lot of work that needs to be done here. Network policies, again, we're excited to hear what's coming out. We're also working with our own internal Contiv folks on this and really taking network policies from just a host layer, which is kind of where we're operating now, where we're putting each host as an endpoint within EPG. Think of it kind of like a policy group. And we are dictating essentially ACLs or filters on what can access or not access those hosts. We then node label those hosts to dictate out certain workload behaviors so we can have stage, dev, prod all running in the same cluster while only having access to certain things limitedly. We're really looking to take and hoping that the container will eventually become truly a first-class citizen on the network and really kind of expanding and fully taking advantage of everything that containers have there.
Let me jump in here, Mike. To
Sure.
me, this is the holy grail.
Yeah.
I mean, I've been waiting so long to be able to do a multi-tenant shared PaaS platform and be able to specify application-specific network policy. And it's not a OpenShift problem. Anytime we've been running Java JVMs on a consolidated platform for 15 years, and it's the same problem there. We can only define policies at a host layer or a group of hosts or the cluster layer. So if any of you guys solve this, let me know.
And actually, I thought the proposal, I forgot who did it, but using node ports was something we looked into as well, but we didn't have whatever tool you're using as part of your CI/CD pipeline to manage those ports. I wish we did, though, because it would have made our lives a lot easier. IPv6, we really, really want it. We're running out of public IPv4 addresses at Cisco. IPv6 is really the path forward for us. And we're kind of stuck. And so if you guys happen to be working on that proposal Clay was talking about, thank you. Keep up the good work. I'll buy you a coffee or something. We'd love to see that take place. And then dynamic secure host path. This is something else we're also very much looking forward to. It was a requirement right from the get-go for us that we needed very low latency, high I/O, high throughput storage for some of our clustered database use cases. And while stateful sets help solve part of this problem, as you guys probably know, host path is really only enabled for single node deployments. We've done some workarounds. We've been able to figure out a way to kind of securely attach local storage without exposing or making the container root to that container, have it mounted, and we're using the out-of-tree dynamic storage plugin for that. And we've modified that to allow some of this other feature sets. But we're really looking for an in-tree solution. And then security. Right now, we have great visibility. And that's something from an IT organization we've historically have struggled with. And when we were pitching this to our own internal InfoSec team, it was something we kept espousing over and over and over again. And they were very impressed by that. Looking into the future, again, you'll see kube federation all over the place here. We really see this as the way future for a lot of the problems that we're facing today. Things like unified experience across clusters, we see the kube federation model really helping out there. The service discovery, kube federation helping out there. Cluster failure, kube federation helping out there. Again, we're still looking for a good scalable ingress-egress solution. We're working with our own internal teams about that as well as with Red Hat. And we're really looking forward to some stuff coming down the pipeline in that front. Networking policies, native IPv6 support. And with security, I kind of want to stop here for a second. We need more than just visibility, right? We need the ability to enforce and have some form of compliance around this. And so the ability to not just image scan a Docker image and say, oh, it's good, but then tie that into lifecycle management as well. And be able to associate that with containers running in different environments and different stages, and be able to enact some sort of policies around that and dictate what is okay and what is not, at what point, when to kill it, when to keep it alive. And again, we were very happy to hear that Red Hat's also thinking about doing that in the near future. It's something we're pretty stoked about. So as we kind of take a look at our cloud evolution, at least within Cisco, we start off with the data center. And I actually had to look this up. Cisco apparently started in 1984. And so we started off with data centers. I don't think we had mainframes. I know you weren't there, but yeah.
I've been there a long time, but not that long.
And as early as 2002, we deployed our first PaaS solution. So we've been in the PaaS game for a while. And in this scenario, the data centers run pretty much any and every workload, right? You can install almost anything on bare metal and have it go. When we introduced our PaaS solution, we kind of segmented some of that away for our web apps and streamlined and made that experience better. 2008, we like everyone else, rode in with the VM revolution stage. And with that, kind of introduced this notion of infrastructure as a service. So now really the data center and bare metals have been regulated to, well, mostly databases and solutions that couldn't really survive or handle the hypervisor cost. And then we built our PaaS solution on top of that, and we continued serving out web apps. Everything else, for the most part, ran within VMs. 2010, we actually started our journey towards we call it MVDC, or multiple virtual data centers. Basically, it's just a fancy internal marketing word for high availability across data center failure. And so we have 2 sites in Texas where we typically do this in Allen and Richardson. They're, I think, 20 miles or less apart. Like that, yeah. And so it allows us to take an entire data center outage and still keep everything up and running without any problems. And a lot of that was handled through hypervisor technology and VMs. 2015, if you notice, we switched from a PaaS to CaaS, something that Mike White was kind of talking about. And this notion of availing it more than just web apps, but now also enabling microservices. And here we are in 2017, and we start talking about introducing this another abstraction layer called the cloud, or CAPI, ACC, these federation models, elevating up not just web app-based workloads, but also microservices. But as we deploy CAE, or our CaaS infrastructure, onto bare metals as well as VMs, we can start actually utilizing databases that were pre-existing, kind of nailed to bare metals only, because we remove that hypervisor tax, and we can avail direct, strong performance to the container, because again, a container at the end of the day is just a process running on the operating system, and really leverage multi-tenancy and shared infra at the bare metal layer for, in this case, databases. Going forward, we're looking at public cloud, just like everyone else. Sounds like we're a little late to this game, actually. We are also talking about using OpenShift, or our CaaS infrastructure as an abstraction layer there, and then bridging using hopefully Kube Federation as well as our own cloud API and services to kind of bridge that and serve out all those use cases. Taking a step forward, after that, our hope is we can start providing managed services, and again, we're very excited to hear that a lot of work is being done on that front, where we can start thinking about serving up IT as a customer of IT and serving out as a services. So databases as a service, message queuing as a service, Jenkins build times as a service, ID as a service, machine learning, big data as a service. And that's a lot of ases. But all these things, they're important. And again, this is kind of fundamental to the way IT has to evolve and to better service our own clients. So why hybrid? Well, Cisco's a very large organization. I think we have 150,000 employees worldwide, somewhere around that. I don't know how many countries we're in, a lot. And most of our data center footprint today is in the United States. And as we look at servicing our own internal clients in EMEA, or Europe, Asia Pac, Africa, Australia, all these different areas, having data in the services located in the US just doesn't make sense from latency and performance point of view. Oh, hit the wrong button. There we go. There's also notions of data sovereignty. So the countries, and if anyone knows of any more than this, let me know. The countries kind of labeled there in the light blue not including the US, it doesn't really differentiate here, are the ones that we know of today that are looking into or are implementing in data sovereignty rules. And so places like Germany we're looking at of hosting public cloud service, because we don't really necessarily have enough workload to warrant us building out a whole data center there, but we need to keep that data in Europe. And so we're starting to look at public cloud as a way to solve some of these use cases for us. You want to take this one?
Sure. So Mike mentioned that Cisco is a big company, a lot of employees globally and a lot of customers globally. So beyond data sovereignty, which is kind of the urgent pressing issue, we've got just basic usability issues. Can we put the applications and the data out closer to our customers, giving them better global presence, global performance, and availability, right? You know, all of these abilities can be improved by deploying the app closer out to the customer or the user of the application.
And then obviously the biggest use case, you often hear about hybrid cloud solutions, and that's the elastic capacity. So when workloads all of a sudden increase, you can burst into the cloud without having to maintain a large foundational footprint of private infrastructure. Allows us to save money in that way. And I think that's it. Does anyone have any questions?
Question down here.
Yeah, I'll take the one up front, and then we'll take the guy there in the middle.
Thanks. I don't know how many users you have delivering OpenShift Blueprint to you and how long you train them to use OpenShift the best way. So my question is, for instance, memory or CPU requests and limits. Do you expect them to set the right requests, or do you do it yourself, monitoring the data? How does it work?
So we've made that programmable. Much like the previous presentation, we set what we think is a kind of a minimum default. So if you don't specify, the developer will get a small quota. We expect people to overrun it, and then we have a request quota API that we've also made available. So they can keep increasing it. All of this is tied back to our costing and budgeting systems, so they can increase it up to the amount that they can afford, right? So requests and limits are a bit of a tricky situation, and then you start factoring in overcommit. So there is a learning curve for developers there who may think in terms of their Java heap size, you know, so they might need to play around with it a bit.
And frankly, a learning situation for us as well, right?
Yeah.
So a lot of these workloads, performance ratios are new to us. So we could look back and say, okay, these are our JVM workloads. We kind of can model that from the past year and try to get an idea of what ratios and how much they're going to be using. We could take a look at even Jenkins build farm to kind of get an idea. But at the end of the day, there's going to be a lot of new workloads. In fact, there already are a lot of new workloads with very different performance factors than we've ever seen before. And so in the overcommit ratio part of it, we're constantly having to kind of monitor that and learn on our feet and adjust as needed. But the benefit here is that all this is programmatic, so that it's very easy for us to continually fine-tune the environment to match the needs of the actual running infrastructure. Along with training, that's something we're working really hard on building out and helping our developers learn about microservices. There's like any new kind of, I don't want to call this a fad because I feel like this has a lot more feet than that, but any sort of new thing people get excited about. But they jump into it not with an old world kind of mindset.
Yep.
And so helping them kind of transition from that old world to this new world of microservice architecture and cloud and horizontal scalability is something we've been putting a lot of effort into and something that we actually need to do more about. Because that's really going to drive, at the end, the best overall experience. Thank you for your question, by the way.
Just real quick, you've been on this journey for a few years now. You talked quite a bit at the start about your consolidation, rationalization of your infrastructure and how containers kind of took away that hypervisor tax, so to speak. Just curious as to what sort of efficiency you think you've gained over the last few years by using containers, either by percentage or dollars or, I don't know, price performance or something like that.
I can do
You crunched all the numbers.
And any sort of color you could add to that, how you came to that justification?
Yeah, to get into specifics, I'll probably need to grab your email and I'll have to pull up those docs. It's been a while. But the journey is just kind of starting for us. So When we initially built out our container platform in 2015, it was all on VMs, mostly because that's where the available infrastructure was for us to consume that. As of this year, though, we've gone ahead and deployed a significant amount of bare metals throughout the United States, and we're augmenting our environment with that. And what we're doing first is pushing our heavy workloads onto those, and those that specifically require local storage, local SSD, low latency, high bandwidth. And so we have some theoretical numbers as to how much we'll probably end up saving, but we don't have actual numbers yet. We'll need to let what we currently have run for a little bit longer, and then we'll have actually something better. But just knowing that VMware, which if you guys don't know, I'm not going to bash on them here, but their end user licensing. Huh? Oh, thank you. We love your stuff. We run it.
Busted.
Whoops. We're a very big customer. We are. We have tons of VMware. Please don't revoke our license because we'd be hosed. But their end user licensing agreement doesn't allow for publishing of performance numbers. So it's actually hard to go online and kind of see and figure out exactly what the cost is of the hypervisor. And so, so I'm not going to publish what our numbers are, but what I've kind of talking with other colleagues outside of Cisco and kind of what I've heard is roughly around 15% capacity loss. But then there's also around, I've heard anywhere from 3% to 12% performance loss on a per VM basis. Right. And so it's not just capacity on a per compute host basis, but it's also performance of the process running within the VM that you have to take into account.
Yeah, there's two other things I'll add to that. One thing that we're concerned about and why we're moving to bare metal is the double scheduler kind of layer. Our VM environment is large and general purpose. And so there are policies set at the VMware layer about vMotion and DRS, and we don't want our nodes in this cluster popping up and down and
we want them
moving
sticky.
around.
We want them locked to nodes. We want them to fail.
And it's not that VMware can't do that. It's that
Right.
our policy at Cisco on this large general purpose cluster doesn't allow it. The second thing is that the diversification. By allowing different application workloads to come onto the platform, we are seeing a diversification benefit where our previous platforms as a service were all Java web apps. So very memory intensive, and our utilization really just stunk on the CPU. I mean, we might as well not have even bought CPUs. Very, very,
at least one core.
At least one on each machine.
At least one core.
Yeah. But now that we're doing these data services, we're seeing that kind of stacking effect where our newer workloads are much different than the original ones that we
And
used.
then to kind of the point that Michael was making about VMware and this double scheduler kind of issue, we also run something called Turbonomics, or VM Turbo, which helps us manage and kind of schedule our VM workloads and right-size them to kind of increase our efficiency at that layer. And we've had a lot of issues with kind of dual split brain, where on one hand, OpenShift is doing a very good job of handling its own resource utilization, and then underneath it, our hypervisor layer is constantly changing. It's like, no, this needs to be, we view containers as a first-class citizen of the data center. It's not something that's just another platform that sits on top of VMs. Does that answer your question? All right, cool, thank you.
Thank you very much. Great session.
Are we done?
That's it.
All right.
We have-
Thank you.
Good job. Thank you very much.